Okay, today, in your text for the last few days, you started to read the information in a section review over humidity and condensation and evaporation, things like that. What we're going to do today is go through and look at those. The first thing you need to do is in your notebooks, I've got, I believe, 9 vocabulary words that we need to make sure that we know for sure and get those in. So what I've got is a presentation here, a PowerPoint. We're going to put it up here. It's not real dark because of the light, but you should be able to see it. And we're going to go through those words one at a time and make sure you understand each one of those. So copy it down as we go. First word, evaporation. Cooling process by which water is changed from the liquid form, which is water, to the gas form, which happens to be water vapor. Thinking about evaporation, we've talked about several possibilities or examples of evaporation. When we talked about oceans and we looked at principles of desalination, what was one principle that we used in desalination as far as evaporation goes? Somebody remember? Danny? Desalination. One method to use evaporation. Remember what that was?
The water evaporates and the salt stays.
Okay. Salt stays, the evaporation water rises to the top, runs down the side. You can collect that fresh water. Now, evaporation, this is the most important thing you need to know about evaporation is it's a cooling process. And we're going to do a little mini lab over here that's going to look at that in a little bit more detail and give you a better chance to understand that it's a cooling process. And what you're looking at basically is taking water from its liquid phase and putting it to its gas phase. And there are probably 50 different variables that can influence the rate of evaporation, and we'll talk about a few of those too. Is everybody at this? Okay. Other term, the two major ones, we're looking at evaporation, and this is the second one, condensation. Basically, you can say that these two are opposites. You take evaporation, you take water in the liquid form, and you transfer it into water in the gas form. Condensation is just the opposite, where you take water that is in the gaseous form and convert that into water into the liquid form. Condensation, process in which gaseous water, which happens to be water vapor, is changed into a liquid form, which would be regular water. Anybody think they can give a good example of condensation? Or some time when they've experienced what they thought was condensation? Curtis?
Like dew, in the morning.
Okay, dew on the grass. If you happen to get up nice and early, and it depends on the environmental situation, and take off your socks and shoes and go running barefoot through the grass in the morning, your feet might get wet. That's from dew or water that was out of the atmosphere that has collected on the grass. That's one example. Another example of condensation. I'm sure you've all experienced it. Nathan?
When, it's cold outside and you breathe on the window glass.
Okay, that's one. It's cold outside. You go up to a window itself and you breathe on the window. You have, every time you exhale carbon dioxide, other gases, as well as water vapor. The water vapor in your breath hits the window, it cools and collects, and that's condensation. Another one. Rod?
Like when you're cooking and the steam from the pan hits the lid.
Okay, that's one. You're boiling something, cooking something, you take the lid and lift it up, and there's water that's collected. Take the lid and set it on the stove, and then you have water that runs everywhere. Another really good example you've all experienced. A picture from the book. Exactly. You take a cold glass of water, take it out, set it on a table or whatever, especially in summertime, you come back, and then there is moisture all around the outside of it. I did this, here just a little bit. One time I was talking about condensation with these 4th grade kids, and I told them, here's a glass, it's got water on the outside. I want you to tell me how this got here. We need to come up with how it is. And I said, you can only tell me, or you can only ask me questions that end in yes and no. And we sat there for 45 minutes, and they asked me questions. Mr. Kenoyer, no. Yes. Mr. Kenoyer, no. And I said, no. when they finally came up with the reason why condensation takes place. Now, where we know that condensation is water collecting on the outside of a cup. What I want to know is why. This is my question I posed to you. TJ, what do you think? If I take this Pepsi can, and right now I can pick it up and feel it, and it's got water on the outside of it. Why does this have water on the outside of this Pepsi?
It's like cooler on the inside and warmer on the outside, so it's like evaporating.
Like evaporating? Okay, he's got some good points, and right off the bat, he's got pretty close.